Hello everyone, today let us discuss about numerical problems of Wheatstone bridge and meter bridge. And you all know about a meter bridge and also you know about the Wheatstone bridge. You must have done so many experiments using meter bridge. This is the meter bridge and this is the Wheatstone bridge. And I need not tell you about the theory, it is already explained in other videos. And here is the Wheatstone bridge. It has 4 arms. In 4 arms we have 4 resistances P, Q, RS. When the bridge is balanced, that the balancing condition of the bridge is P by Q is equal to R by S. So that is the balancing condition of the bridge. Suppose if one resistance is unknown, P by Q is equal to R by X, where X is equal to Q R by P. This one formula is enough to do the problems of Wheatstone bridge. And next we have a meter bridge, and this is also based on the principle of Wheatstone bridge. And when the bridge is balanced, that is when the galvanometer shows a zero deflection at a particular length L, then we have P by Q is equal to R by X. It too has 4 resistances. I'll just show you the figure of this meter bridge. X and Y are in the place of P and Q, and the resistance of the wire from A to D is like working like R, and the resistance from D to C is working like S, that is unknown resistance X, that in that place like it is working like S. So 4 resistances are X, Y, resistance between AD and resistance between DC. So this is also based on the principle of Wheatstone bridge. So without wasting much time, let's do our numericals. The first numerical I have taken is, that is, in a Wheatstone bridge arrangement, the ratio of arms P and Q are nearly equal. That means resistances P and Q are almost equal. The bridge is balanced when R is equal to 500 ohms. They did not tell us the fourth resistance, yes, but when P and Q are in their positions, when you keep R is equal to 500 ohms, the bridge is balanced. On interchanging P and Q, that means in the place of P you placed Q and in the place of Q you placed P, then balancing, we got the balancing, that is galvanometer shows zero deflection when R is equal to 505 ohms. Then what we have to do is we have to find the value of X, that is the first part, and second is we have to find the ratio P by Q. Okay, so let's start our solution. Let's start our solution for this first problem. Now the first problem is, first when for the balancing condition we all know P by Q is equal to R by X. Now case 1, that is case 1, they have given R is equal to 500 ohms. In that case, we don't know P and Q. P by Q is equal to 500 divided by X. Let it be equation number 1. Then what they have done is they have interchanged them. That means they have done Q by P, then R was, that is case 2, let me write here. In this case 2, R is equal to 505 ohms. So here what happened is, now in case 2, now if you see Q by P they interchanged, R is equal to 505 divided by X. Let it be equation number 2. So we want to know the value of X. For that, let us multiply equation 1 with equation 2, that is P by Q into Q by P is equal to 500 by X into 505 by X. We are multiplying equation 1 with equation 2. So here P cancel and Q also cancel. Then that is 1 is equal to 500 into 505 divided by x square. Therefore, x square is equal to 500 into 505. Okay, then after that, therefore, x is equal to under root 500 into 505. To simplify here, it takes time. Directly, I will write the value which already calculated, 502.5 ohms. So, x is equal to 502.5 ohms. It's a simple way, isn't it? Solving the problems, this is really a very simple way. So, this is how we found that unknown resistance. But in the problem, they also asked the second part, that is the ratio of P by Q. They asked us to find the ratio of P by Q. So let's go and substitute the value of x in any one of the equations 1 and 2. Easily you will get the value of P by Q, that is ratio. Here x is equal to, here you can see equation number 1. This is the equation number 1. P by Q is equal to 500 by x. Let us take that only and then substitute, that is P by Q is equal to 500 divided by 5, x means 502.5, then it comes by around 1 by 1.005. That means P is to Q is equal to 1 is to 1.005. So this is the ratio which we found and which they asked us to find. So here we have completed the first problem. Now, without wasting much time, let's go for the second problem, that is a meter bridge. Yes. So here we have the second problem. In a meter bridge, the null point is found at a distance of 40 centimeters from A. If a resistance of 12 ohms is connected in parallel with S, the null point occurs at 50 centimeters from A. Determine the values of R and S. First time when null point is found at 40 centimeters from A. Then after that, with the resistance S, another resistance 12 ohms is connected in parallel. Then null point occurs at 50 centimeters from A. Then what is the value of R and what is the value of S? So that is our problem now. So let's start our problem. So this is the meter bridge, you can see here. This is A and this is C, clearly you can see. From A, first time we got that at a 60, and after that when they have connected a resistance in parallel, so first time they got a null point at 40, I think. Let me go back to the problem. Yes, 40 centimeters. After connecting a 12 ohms in parallel with S, the null point occurred at 50 centimeters from A. So this is the meter bridge. First time when these values are there, the null point got at 50. Then X place we have to imagine R, Y place we have to imagine S, that is R and S. In place of S, they connected 12 ohms in parallel. Then the null point we got at 50 centimeters. Now what is our problem is, we have to find the values of R and S. So let's start our problem, that is problem number 2. So first time let us take R by S, that is equal to L by 100 minus L. It is a meter bridge, that is length of one wire is 1 meter, that is 100 centimeters. That's why we take 100 minus L here. That is all theory. First time we got at 40, then 100 minus 40. Therefore, R by S is equal to 40 by 60, and you can cancel, then you will get 2 by 3. So keep it one side. And after that, what they have done is they have connected one parallel resistance 12 ohms with R. So you can see, let's go back and see, this is our meter bridge. Here in place of S means in this figure it is Y, they have connected a parallel resistance that is 12 ohms. Then what will be the resultant? So then first we calculate the resultant of the parallel combination of 12 and S, then once again we will proceed. Okay, so let's go and solve that one. So now what happens is, with R, one resistance 12 ohms is connected in parallel. So what happens here is, you will get the resultant resistance will be whatever it is, that is R1 R2 by R1 plus R2, that is R into 12 by R plus 12 according to the formula, that is we will get 12R divided by, it is connected in parallel with S, I think. Let me go back and see. It's connected in parallel with S. It's connected in parallel with S. Please note this, not with R. It is 12 ohms is connected in parallel with S. So let me rewrite it. It's not in parallel with R. It is in parallel with S. So now we will get S in parallel with 12. So S into 12, R1 R2 by R1 plus R2, S into 12 by S plus 12, S into 12 by S plus 12, and you will get, that is 12S by 12 plus S we will get. This is all in the place of the second place, that is, now we will do the problem again, that is R by S is equal to, now that is 50 by 50, but S is in parallel with the 12, therefore we will rewrite it, R divided by S parallel with the 12 means, that is 12S by 12 plus S, that is 50 by 50, that is equal to 1 by 1. Therefore, let us write now that we will get R divided by 12S into 12 plus S is equal to 1 by 1. Therefore we finally R by 12S is equal to 1 by 12 plus S. I have sent 12 plus S to the right side. Then R divided by S is equal to 12 divided by 12 plus S. 12 plus S, because that side we have 1. Okay, so now R by S from, let it be equation number 2. But R by S from equation 1, R by S is equal to 2 by 3. So let us substitute that. R by S is equal to 2 by 3, that is 2 by 3 is equal to 12 by 12 plus S, that is 12 plus S into 2 is equal to 12 into 3, that is 24 plus 2S is equal to 36. Therefore, 2S is equal to 36 minus 24, which is 12. Therefore, S is equal to 6 ohms. And they also asked us to find r. So from to find r, you can use this equation 1, r by s is equal to 2 by 3. So we can use that r by s is equal to 2 by 3. R by s is equal to 2 by 3. That means r by s means 6 is equal to 2 by 3. Therefore, r is equal to 2 into 6 by 3, that is 4 ohms. So this is what we got the answer now. So S is equal to 6 ohms and R is equal to 4 ohms. S is equal to 6 ohms and R is equal to 4 ohms. So what happened here is they have connected one parallel resistance with the second arm. Then we had to calculate that the values of R and S. So with this, the second problem is over. Now we have to go for the third problem again. So third problem, let's see, this is the third problem. The same meter bridge, the following figure shows the experimental setup of a meter bridge. The null point is found to be 60 centimeters away from the end A with the x and y in position as shown in the figure. Okay, as shown in this figure. Then what happened? When a resistance of 15 ohms connected in series with y, now it is series with y. Earlier problem it was parallel. The null point is found to shift by 10 centimeters towards the end of A of the wire. That means earlier it was 60, it is shifted towards the A. That means what happens now here is, that is earlier it was 60, now towards A 10 centimeters. That means 60 minus 10, we got it at 50 centimeters. Now find the position of the null point. Again, if a resistance 30 ohms is connected in parallel with Y. So first let us start our problem with whatever the data they have given. Let's go and start our problem. So problem number 3. So let us write case 1. So case 1, first time x by y is equal to 60, they got null point. 60 by 100 minus 60, that is 60 by 40, that is nothing but 3 by 2. Okay, so x by y is equal to 3 by 2. Let it be equation number 1. Then after that case 2. Case 2 means a series resistance is connected with y, that is 15 ohms is connected. You can go back to the problem and see. So you can go back. So here they have given clearly, that is a series resistance of 15 ohms is connected with y. So that we are taking in series with y. Now what happened? The null point is shifted 10 centimeters towards A. So what we will get, that means 60 minus 10, 50. X in y in series with 15, that we got null point 50 by 50, which is equal to 1, Therefore, let it be equation number 2. Now let us multiply equation 1 and equation 2 like what we have done earlier. X into y into x into, sorry, just a minute. Okay, so what we will do is now, let us divide equation 1 with equation 2, that is x by y, then divided by x by y plus 15 is equal to 3 by 2 divided by 1. Okay, it's not multiplication in every case because we want the solution. Then x by y into y plus 15 divided by x, that is equal to 3 by 2 into 1. Then you can get x and x cancel. You will get y plus 15 divided by y is equal to 3 by 2. And finally, once you simplify, 1 plus 15 by y is equal to 3 by 2, then you will get 15 by y is equal to 3 by 2 minus 1, that is 3 minus 2 by 1, that is 3 minus 2 by 2, that is 1 by 2. Therefore y is equal to 2 into 15, that is equal to 30 ohms. So our first one we found, that is y is equal to 30 ohms. So this is one value we got here, and we also need x value. So for that you can go to equation 1. X y is equal to 3 by 2. Let us use that equation. And find then, that is x is equal to 3 by 2 into y, that is 3 by 2 into 30, that is equal to 2 15ths, that is 45 ohms. X is equal to 45 ohms. Now we got the second value. And the problem is not over. They asked, when a resistance 30 ohms is connected in parallel with y again, what happens, where we get the null point. So let's go for the third part of this problem. When, let us case 3, let us say when y is connected with a parallel combination of 30 ohms, let us say the resultant is y dash. So y dash is equal to R1 R2 by R1 plus R2, that is equal to just now we got the value of y as 30 ohms. Therefore 30 into 30 by 30 plus 30. Just now we have got y is equal to, just now we got here y is equal to 30. That I am substituting here. Then you will get 30 into 30 by 60. Then you will get 15. The resultant is 15 ohms. Therefore, now we have to find the null point, that is x by y dash is equal to L by 100 minus L. That means x means just now we found 45, y dash means 15, L by 100 minus L. Okay, so that means we get, that is 15 3 times, that is we get 3 is equal to L by 100 minus L, that is 300 minus 3L is equal to L, or 300 is equal to 4L, that gives rise to L is equal to 300 by 4. L is equal to 300 by 4. Therefore, finally you will get L is equal to 75 centimeters. So this is the answer for the last part of the problem. Okay, so because they asked finally when y is connected with a parallel position, that is parallel resistance 30 ohms, where will we get the null point? Therefore L is equal to 75 centimeters. So like this you can easily solve the problems. Numericals are not a big problem if you slowly think about them and if you know the formula. I have already given all the formula here, like so using these formulas, like easily, very easily you can solve these problems. Okay, so let's meet again with some more numericals in the coming video. Till then, bye. God bless you all.